All right, everyone. I think the seats are filling in. So let's start. Yeah, welcome again to this week's webinar. It's about front-end performance testing in practice. So we will record the whole session. If you have any questions, there will also be a Q&A afterwards. So feel free to put the questions in the chat or in the QA box that Zoom should provide you. And we will make sure to send the recording to all the interested parties and make that available afterwards. All right, let's talk about front-end performance. First of all, who is talking to you? So my name is Jonas. I'm a solutions architect at Platform.sh. Many of you know Platform.sh. This is not a product demo, so we will talk mostly about the workflow itself and not about our product in particularly so much. My job as a solutions architect is basically to make people successful on Platform.sh, providing hosting in the cloud. I am from Germany, so if there should be any accent, please excuse that. Why do we even bother? Why do we even care about front-end performance and front-end performance testing? So when we look at this, this is a map and a statistic from last year about the average internet speeds in the world. Platform.sh as a remote company allows us to travel a lot, so I do that. I've been in a couple of those countries already, and everything that is like dark red or yellow or orange is something that is not your like fiber connection that you probably have. So what does it mean in practice? And like I said, I travel a lot, and the Wi-Fi is usually the first thing that I check. So I live between those worlds, between Marrakesh and Morocco, where there's basically no internet, and in Estonia, which has like a very high, good connection. And being a German, there's also the German train. So at some points, it is actually like performance is relevant because you don't have always your very fast fiber connection ready, and people all over the world, depending on the markets that your site is on, might suffer a lot because their connection is not what you expect them to have. The other thing is not only the connection, but also the devices that come to your website. So this is a statistic again for the time it takes to process all the JavaScript on CNN.com from different phones. And we know that phones are used a lot in the world, especially in lower end markets, to access your site. So what we can see here is that especially the lower end mobile phones who don't have the latest and greatest iPhone CPU struggle a lot with processing your JavaScript. So in general, the less you put down the wire, the better. And the more efficient it is, the better for those phones. So those are two technical things when it comes to why do we even bother. But there's of course also a business reason. So I have two slides about that. If you want to convince your manager to give you more time to work on improving the performance of your site, those might actually work better than the actual technical reasons. So what you can see here is that Trainline has reduced latency by 0.3 seconds in their whole checkout process. And due to that, customers spend an extra £8 million on their site over the next year. So this is a huge increase by a relatively small amount of improvement even. The same goes for Pinterest, where they last year, they reduced their JavaScript significantly, and time to interactive, we will talk about what that means in a bit, reduced also significantly, which means their revenue went up, their signups went up, their active users per week went up as well. So even if the technical reasons are not enough, the business reasons definitely are. All right, but if we want to care about front-end performance, we need to have some way to measure it, right? And you might all seen the usual Lighthouse task, and the goal is, of course, you know, the more green the better, the more points the better, the faster the better. But what does that even mean? If we look at this chart, it's a good explanation from Eddie Osmani from Google, who explained different KPIs based on what's happening when you are actually visiting a site. So from the point on the top left, where we have, you know, you type in a domain, a URL, you wait for something to happen. This is the first critical path, because you want to have that as fast as possible, because users might not be sure if they made a mistake, do they even have a connection? If they have a connection, is the site responding? And then, so this is where the first contentful paint is very important as a KPI, for example, because it means there is something happening, navigation is visible, people are seeing that there is something happening. So they are ensured that everything is set up on the device correctly, they have a connection, and the site is probably working. And then the next part is the site even useful? So to help people realize what's on the site, how the site looks like, and where the most important content is, they need to see something, right? So the first meaningful paint, as well as the part where the site is visually ready, is also quite important, because it signalizes the user that they can, you know, look at the site and react to information that it's giving there. And then also quite important is the time to interactive, which means, can I actually use the site? The site is loaded, maybe it's even visually complete, but it's still doing some background tasks in JavaScript, for example, and people can't, you know, scroll the site or use it until that is finished. So this is also quite critical. And while the different KPIs that are mentioned here are important, it is actually even more important to understand that not one KPI will be responsible to measure your site, but the combination of those. One of the things that you see quite often when it comes to performance KPIs is the speed index. And for all the math nerds in here, this is the complete formula. But it basically measures the time until your site is visually complete. And it is especially useful for comparing different pages, or for even comparing your sites with others, with your competitors. So what are goals? Like, those are KPIs. What are a couple of goals that are good to track and we can set up relatively easily? So first of all, we talked about the amount of JavaScript that you want to send to your users, and that, as a rule of thumb, again, depends on your application. Bigger applications tend to use more, but as a general rule, try to send as little JavaScript as possible down the wire. If you can stay under 170 kilobyte, that is great. Under 5 seconds time to interactive would also be very great, because after 5 seconds, users actually tend to don't want to wait anymore until they can actually use the site. The speed index is, as I said, a relative KPI. So what you want to have is be better than your competition. It is also very useful to track actual improvements of your site. So compare your own website with before and after a change you made in your front-end code, for example, to track if there is actually an improvement, or if you maybe hit a significant change that increases that even, which you don't want. And a more technical KPI is the time to first byte. So this time when the server starts responding to your devices should be under 500 milliseconds, ideally. All right. How does it look in actual practice? There's a warning here, because every time you see a slide like this, from now on, I will try something stupid and do a live demo, so bear with me if that works. There are different types of performance testing: proactive, reactive, and passive. And we will go through them, but that slide is meant to give you a little bit of an overview. So we have proactive testing, which is something that, as an engineer, you can do during development on your local machine, which means you can identify and fix performance measurements even while developing and making sure you have some basic testing done before it even hits your Git repository. What you can do is use your browsers or all the dev tooling around that and other local tooling. So there's not really a specific dependency that you have. Most of the things you will already use. And then there's reactive user testing. This is where not only the engineers can help, but also your product owners, project managers, and others as well. Because the idea is that with every build, with every deployment that you do, you will track certain performance KPIs and see how they develop based on your changes. So what does it mean? It means you can set up automated performance budget and integrate that into your CI tooling to make sure those tests run automatically, and your team can actually look at them or track them. Again, we will have a look on those as well. And then there are passive performance, and then there's passive performance testing. And this is where not only your engineers and the product management, but also the marketing comes in. So this is especially useful for the time when the site is already deployed and live and people make changes to it. So I'm talking about marketing teams adding a couple of beloved tech manager scripts to it that are third-party dependencies that usually slow down the site as well. Something you don't necessarily see in the development process, but see when the site is live and deployed. This is also something that can be done constantly and of course has to be automated. So there are tools for that, like real-time user monitoring, or even standard Google Analytics can do that. We will have a look at those as well. So let's dive into those a little bit, starting with the proactive tooling. I want to show you a nice feature that maybe you already know, but that DevTools have for very basic testing, and also talk about JavaScript package sizes. So let's leave the presentation here and go into a live demo. So one of the first things that you can do, one of the first things that you can actually do, even if you run your site locally, and my demo application is just a beloved to-do app that runs locally on my machine now, which of course makes it load very fast because it's local. But what every browser, this is Chrome, but others have that as well, allows you is to actually test your site under different conditions. So you have usually different presets. So you can simulate a fast 3G connection or a slow one, or even set your website to offline and see how it behaves without a connection. You can also hit custom profiles. So if you want to specifically test a high latency setup, for example, how the site behaves in Australia, which usually has high latency, you can even add custom profiling. But by throttling your connection, you can actually test, if I say the slow 3 and hit refresh, it will take a lot longer than before, and you can look at the network chart to see where the bottleneck might be, how long it takes to actually load the site. And we can see that under a slow 3G, this is taking a lot of time already, and we are way after our 4-second goal. So this is very easy because you have the browser, you have everything, you don't need to install anything for that, and it can be integrated in your usual testing. Relatively easy. The other thing that we can use is we can have a look at our package sizes. So let's say this is an application that is built on Vue.js, but it works the same way with modern React or Angular or most of the other JavaScript frameworks that use Webpack nowadays. And when we run a build, we can integrate something called the Webpack bundle analyzer, which will give us an insight on the different dependencies that we have. So the build has succeeded, and I have this report from the Webpack bundle analyzer that I can open. And this report, again, can run that locally. This report gives me an overview on how the different dependencies are impacting the overall size of my JavaScript package. So in the console, we see that there's a lot of vendor dependencies and the application JavaScript code itself. And the same thing is visible here. The whole gray brownish part, everything is for the vendor files, and the blue one is what my custom code actually looks like. So demo application, so there's not too much in it. But so what I can see here is that, of course, I have the Vue runtime itself or the React part or the Angular part, but I was obviously using Lodash as an external dependency for a couple of things. And this is taking up a lot of space. So this would be a good indication to look into this and see if you really need that dependency, if you can use it a little bit slider, if you can build it with vanilla.js, or if you can just import the necessary parts. So this is also something that is quite easy to do and to integrate on your local machine. We will come back to this later to see how that can be improved. Okay, let's get back to our presentation. All right, reactive performance testing. We have, let's talk about consumption and budgets, and let's also talk about automated tests. Consumption and budget is something where you can define in your build process how much JavaScript, for example, you want to send, and define thresholds, how big you want it to be, and get a warning or even an error to make sure you don't get over those. And automated tests is using, for example, something like Lighthouse as a tool and integrate that in your development workflow, as well as something like the WebPageTest. So Lighthouse is something that comes with every Google Chrome browser, and you can run those tests also locally if you want. But we will have a look in a bit how that can be automated even. And WebPageTest is a little bit different because it has similar tests. Some are different, and there's some overlap between the two tools, but WebPageTest actually runs the test in a real browser from different machines all over the world, and you can define that. So let's see how we can improve the JavaScript package that we have and how we can integrate those tests in our development workflow. So again, it's time for a little live demo. All right. Jumping into the code, one of the first things actually is the split chunks mechanism. So this is something that Webpack offers by default. What it does is, just jump it out. What it does is, instead of sending a big chunk of all the vendor files in one JavaScript file, or if you have more custom code, a huge single JavaScript file, it can actually split that into different smaller files. The nice thing is that this is based on the views that you have. So let's say your user doesn't walk on your website, look at your website, and doesn't go onto the profile page. So why should you load the JavaScript that is needed to display the profile, for example? As it is based on views, it will only include, and the browser later will only use that part of your JavaScript application that is actually needed to run the specific view. So you don't need to send 2 megabytes of the combined JavaScript file. You can send that in chunks and only load the relevant files when the user actually browses the site and needs them. So this is very handy, and Webpack can do that automatically. You don't even have to take care of anything. There's not much configuration going on. The only thing that you can or that you should define is the minimum and the maximum sizes you want. Of course, if you set the minimum size too low, you end up with hundreds of potential JavaScript files, which is also not what you want. And the other thing that is nice and handy to integrate in the development process is actually a warning, or you can even use an error setting here to give you a hint. What does it mean? So let's run the same command again. Let's build our application. And basically what we say is we want to have that threshold. So I don't want to have my application to send down assets that are larger combined than around 100 kilobytes. So what Webpack tells me during the build process is that I did exceed that limit. So of course, 100 kilobytes is very low and very conservative. We talked about 170, but you get the idea. You can adjust that depending on your application. One of the options is to set that as a warning and just have that visible during the build, and see that, and you can react and make adjustments that are necessary. You can even set that to error, which means your build process would actually fail if those limits are reached. This is quite harsh, but depending on the how strict you want to set up your build process, this can also be quite handy to make sure. There's a lot of Node modules around there. Everything has an npm installed somewhere that is just like small and handy helper, but many of them are actually quite huge, and you end up with a lot of JavaScript down the wire without even knowing. And this makes sure you have that visible and you can track that. All right. The other idea is that you can integrate those Lighthouse and WebPageTests automatically. This is where we jump into our platform YAML file and do a little bit of product here, because what we are doing here is basically tell our application in the post deploy hook, which is something that runs after your site is deployed, so it doesn't block anything, to run a Lighthouse test and as well as a web page test. Those are automated. Let's run that on master first, and to have a baseline, and then do a little bit of a improvement and see how that behaves. So we made our changes. Let's commit them. Add tests and push them. So this will deploy my latest code to a Platform.sh project that I've set up before. While it's doing that, let's just jump in what it actually does. First of all, there's the Lighthouse test. So as we know, Lighthouse runs inside the Chrome browser. Luckily, we have a headless browser, headless Chrome, available as a service on Platform.sh, so we can make use of that. What it does is it uses our config reader to get the latest domain from the specific environment that I am on. And you can use the Lighthouse library that they provide to trigger a test. So what I've been doing here is you can set up different flags. You can connect to the headless browser and then run Lighthouse. Here, I am just logging out the actual overall score, but the result that you get has all the KPIs that Lighthouse includes, and you can, those are documented. You can use that to trigger any of those KPIs in the process. The other thing, and that is quite similar with the web page test, they also provide a library for that. The only thing you need to get is a key, an API key from them. This is free. That has about 100 requests per day or something like that, free. You can set up one or multiple locations you want to run the test from. So on a very distributed website with different markets all over the world, it could be interesting to compare different locations. And the same logic applies. You get a result that has a lot of different KPIs, the load time, speed index. I am only using or displaying some of them in my log later on, but you have basically a huge JSON object that you can work with to track those. And here I'm just logging out the results in the console, but you could send them to an external service and track historic KPI development of your application if you want, or build even a UI for that. That would be completely up to you, but that works out of the box just fine. Let's have a look here. All right, so like I said, the application is deployed, then the post-deploy hook is executed. That means our website is still running, everybody can use it, it's not blocking anything, it's just executing those tests. And there's a lot of logs. And here we have the Lighthouse score, which is 95 out of 100, not too bad, but maybe we can do something about that. And we also have something like the speed index and the other KPIs in here from our web page test. You can even get the result on their website as well if you want to go deeper into that. So that is nice because basically with every push, I can track that. So let's do that. Let's work on a branch and make some changes to our application. So remember when I talked about the Lodash dependency that was using a lot of space in the end? Let's try to remove that. So we have, and I'm not going to go into all the details of the code. This is just the sample to-do application. But what I'm using Lodash for is, in this view, is I'm just using the sort by function to sort my to-do list. So probably this can be done a little bit easier. So instead of Lodash and the whole external library, we can use a vanilla JS function for that. So this adds a little bit more code to my view, but it allows me to remove the complete Lodash application. So with those changes, let's check. And let's just deploy that. Remove Lodash and push that. So nice thing about Platform.sh is I can test that out on an own environment. So this will be using a different URL, but I can make sure everything works before I actually deploy that to master and run those tests and make sure I actually worked on the performance the way that I expected it to be before merging that into my master site, which makes sure that everything that I've done actually didn't decrease the performance of the site. The site is already deployed, so it will run my Lighthouse test first. Should be there in a second. All right, so first of all, I got my Lighthouse test, which is, well, a little bit of an improvement. So from 94, we got to 97, nice. And then it's running the web page test. So this should take a little bit longer since it's an external dependency. It needs to call the external website, get the slot, and work on that. The nice thing again is I can still browse the site while it's doing the test. So if I open that, I have everything. I can use the app if I want to, and it will use that domain to run the tests on in the background. And here we are. So those are the results. The speed index didn't change very much. We have the load time did improve a little bit. So it doesn't have to be like a huge increasement. This is just a very small code change that I did, of course, and this is just a demo application. So this just shows you how to integrate that performance test, to automate that, and have that with every git push run in the background, and to make sure you are actually aware of any performance effects that your code changes have. And this can be added in a very, very easy way. You can also use external CI for that, of course. You don't have to use that on Platform.sh, but it comes quite handy, of course. All right, so much for that. Let's continue. And of course, there is passive testing as well. So one is the real-time users that you want to monitor, or that you can monitor, and then there's constant monitoring of those performance KPIs as well. I have two tools. I don't want to go into much detail. There are multiple of those, and those are not I'm not associated with them. This is not an advertisement. Those are just two tools that I found out are very useful in a day-to-day business. One is very well known. I think this is New Relic. New Relic can not only be used to get insights on the infrastructure level on the back end, but they also have a product that tracks browser performance on real users. So you basically get an overview in this screen, for example, of the page view, the load time that actual users are experiencing. So you see different developments, see different effects after deployments, and you can actually track real users instead of just simulating them with Lighthouse, for example. And this, of course, enables you to keep a good track of what's happening on your site. You can even build custom views in terms of if you want to go deeper and analyze different behavior in different markets, see if how the performance looks for users in India compared to users in Europe, for example. Things like that are possible. And the second one, which is more of a passive monitoring as well, is Calibre. Calibre is not so known compared to New Relic, but it has a couple of nice features. You can think of it as this Lighthouse as a service, so it runs that externally as well. But it gives you basically all the possibilities to track those Lighthouse KPIs from an external site, which means you can monitor the site without actively triggering it. So you can set up a snapshot that should run every 2 hours or once a day, something like that, with different profiles. Test the site as a desktop user, test the same site as on a 3G connections, and the same options apply. You have multiple options like the latency in the downstream and the upstream performance, and track that. You can be alerted. So for example, if the site is suddenly, for some reason, because the marketing team added the Google Tag Manager, for example, or added custom Tag Manager scripts to it, and the site suddenly decreases in performance, you can set a budget and even get an alert for that, which comes in quite handy because it makes you aware of the things that happen after your deployment. And their API actually allows you to tag deployments. So all those, I don't know if you can see them quite good, those are gray lines here and here. They are deployments that have been done on the project. So you can see how the performance develops over time, even after specific deployments as well. So yeah, those are two tools that are also quite handy. All right, some takeaways at this point. I hope I made it clear that the performance is still something that is very important, not only from a technical perspective, because there are people in the world who don't have the performant phones or the high-speed internet that you have in your office or even from home nowadays. Collecting data is something that is useful because it actually makes sense to track those KPIs. Without that, you won't even know the effects that your code changes have. It is very easy to automate a lot of the tooling around that and to integrate that into everyday workflow. And we all know that a task that is not automated and only run manually is a task that probably won't happen at the time when you need it. So automate all the things all the time, please, because that's what automation is for, and it is not so hard to do nowadays. And yeah, maybe even one step further, there's a thing, I don't know if Facebook is still doing it. They had it at some point, a day called 2G Tuesdays. So every Tuesday, they would throttle their network for their engineers to a 2G connection. So whenever they access the Facebook mobile app or the Facebook website, they have the 2G bandwidth available only. And that, of course, motivates you a lot to improve performance on your own code, because this is when you see how painful it can be to use your site with a slow connection. So this is maybe something also very radical, but could be interesting to see. I can only encourage you to just use the Chrome network throttling option to see how your site behaves. This is something you can do right after this webinar and to see how it feels on a slow connection. All right, I think we are very good in time. Do we have some Q&A?
We do. So the first question is, for Lighthouse testing in the build stage, can you have it fail the build if the score decreases by a certain threshold?
That would be a little bit of a different setup. So what I've been doing is I used it after the build, actually. So the site is not affected, but we think you could potentially run that as part of your CI build step. That would be possible. On Platform.sh specifically, I wouldn't encourage that because it will stop your site from being accessible. But yeah, in a local CI or external CI, that could be possible, absolutely. It is, in the end, it's just, this is a custom script that runs it. If you can end that within, depending on the results, end that with the corresponding exit code, that should absolutely be easy to do.
The next question is, what about sitespeed.io? Did you already use it?
I haven't used sitespeed.io actually and haven't looked at it deeper, but of course there are more tooling available than the things that I just showed you. I think there are different functionalities, different pricing around that. Every tool is definitely better than using none of them. So there are a couple of open source tools. There are paid versions. They're even on the higher end. There are very, very high-end tools that are quite expensive and gives you even more deeper integration and more functionality. So yeah, definitely worth checking out.
I have one more question for you, unless someone has one they haven't typed yet. It is, what other tests can be useful?
All right. I mean, we've talked only about performance testing, but what you could also do is, besides triggering and collecting those KPIs, you could add something like a visual regression testing in your post-deploy hook to not only test the performance. And of course, every test, as like unit tests or stuff, is also useful. So there are different stages in your deployment. Let's say before you build the application, after that your deployment. Stuff like that. And visual regression testing is something that works quite well also in those post-deploy scenarios, as an example.
Perfect. I think that is it for questions.
All right, cool. Yeah, I mean, I think we covered that. If you have any more questions, feel free to reach out. I will give you a screen with the contact details in a second. One thing I also wanted to mention is that since the time are interesting these days, we also have a ad hoc webinar tomorrow with Rob Douglas from our DevRel team to talk about tools for remote teams. As you might know, Platform.sh is a remote company. So if in these days you are experiencing remote working for the first time and have some questions or even want to get inspired by the tools that we use and we can host for you, feel free to join us tomorrow as well. All right, then, yeah, thank you very much for joining today. Please, everybody, stay healthy and feel free to reach out if you have any more questions or ideas. Thank you.